Hi guys, and welcome to my channel. I go by name Miss B, and today I'm gonna start SAYS exam revision. So starting with 2017 exam paper, you're gonna see that exam paper has been broken into sections, and each section may have either 2 or 3 questions or 4, depends on the length, as I'm trying not to make the videos way too long. So the first one, question 1, is about finding the first derivative, dy dx, of the following functions. It says here, do not simplify your answers. So if you do want to practice just for the sake of doing a little bit more algebra and, getting better and faster at it, you may do it, but while doing exam, there is no need to, as you're going to waste your time, and you do need all these minutes to finish your exam paper. So the first function is y equal to e to the power of x to the power of 2. So what I have done here on this side, I do have this simple one, y equal e to the power of x, and if you do find derivative, you all know it's just e to the power of x. But now sometimes kids looking at this one here, they make mistake, like as I did here. So I'm just going to change that and put here negative. I'm going to use different color, negative x. So what happens that when y is equal e to the power of negative x, y dash is equal negative e to the power of negative x. And oops, I did it again. So now where is this coming from? So there's a rule here, y equal to e to the power of f of x. So when you do find the first derivative of exponential function, pretty much you copy e to whatever power you have, so that's your f of x, and then you multiply by finding the derivative of this f of x, which is here. So pretty much that's what has happened here. You copy e to the power of negative x, e to the power of negative x, and then times by the derivative of negative x, which is negative 1. And that's where this negative 1 is coming from. Okay, now let's go back and start solving this equation. So y dash is equal to, as I said, we just copy e to the power of x to the power of 2, and then times, now this is our function, isn't it? Okay, so this is our f of x. So we do need to find what is the derivative of x to the power of 2, which is 2x. And that would be it. So I wouldn't simplify and just move on the next question. Easy 2 marks. Part B, question B, we have y equal to 2 times x times sin of 3 of x. So what we have here is the product of 2 functions. So we can see that our first function is u equal to 2x. Maybe you're familiar with these u and v's. You can label, you can use any letters you want. Sin 3x. So then we need to find the derivative of each. So u dash, derivative of 2x is just 2. Derivative of v dash is, we're looking here, what is derivative of sin 3x. So what I have done here on the side, I just went through this rule as well. So we have function y equals sin of f of x. Now in order to find derivative, derivative of sin function is cos. Then you copy function that you had with sin, and then times derivative of the function that's in the brackets. So let's do the same here. So we're gonna go cos, we copy, it's gonna have different color, 3x, and now we times by derivative of 3 of x, which is times 3. So you can move, if you want, that 3 in front of the brackets, so however you want to do it, but it's 3 cos of 3x, it's not cos of 9x. So it's this one here. Now, don't forget to go back and substitute this into an equation. So y dash is equal to the product rule on the side. Y dash is equal u dash v plus u v dash. You're looking now what is what. It's 2 times v times 3. It's undo. It's times sin of 3 of x, and then plus u dash u, which is 2x, and times v dash, which is 3 cos 3x. Okay, so like yep, hopefully, yep, you can see that. So no need to simplify. I'm not even gonna look if we can simplify. I will just go to next question. So the next question, it does, we can see there's a fraction, and the best way to find the derivative is using the using the quotient rule. So if we have, for example, functions y equal to u over v, finding derivative would be u dash v. Now take away, not plus as in product rule, u v dash over v to the power of 2. Now you can do similar to what has been done before to find what is your u equal 4x, and then find the derivative, which is equal to 4, and then your v function is 6 take away x to the power of 2. Here you use the chain rule. Yes, you do. So first you deal with the power, so you take that number in front of the brackets, and then you copy the rest, and now this power of 2 will be reduced by 1, so 2 take away 1, it's 1, and then the next one, it's times derivative of whatever is inside. So derivative of 6 is 0, derivative of negative x is negative 1, so it's negative 1. And now you go back here again. Don't forget to go back and substitute, so and make sure that your rules, formulas are correct on your reference sheet. So 4 times u dash times v, 6 take away x, everything to the power of 2, take away u, you're looking what your u is, 4x, and then times v dash times 2, 6 take away x, and then times negative 1. Everything over v to the power of 2. Let's have a look what is v. 6 take away x to the power of 2, and then to the power of 2. And I'm just going to leave it as it is. So let's move on to next question. So we do have a table that gives the probability distribution functions for discrete random variables. The value a and b represent 2 missing probabilities in the distribution function. Explain why a plus b is equal to 0.9. So explain, so at least, you know, I would start with having a statement that, you know, I know that the sum of all probabilities is equal to 1. So if I do know that, I can say, yes, a plus b plus 0.1, it's supposed to be equal to 1. Okay, so therefore, if I move 0.1 to other side, I'm going to end up with a plus b is equal to 0.9. So you have explained, or you have shown why. So given that, next one, part B, given that mean of x is equal to 0, write down a second equation for a and b. So again, we do know in order to find the mean is the sum of all x's times p, probability. So you can have these, you know, i's here, which means I is getting from, you know, 1 to n or 0 to n, depend. Yeah. So, but I'm just gonna get rid of that here. That's fine. So, and let's go back. So now based on this, we do know, given that mean is equal to 0. So okay, I'm gonna replace this by 0 equal to, and now the sum, so of all random variables times by, its probability. So what we have here is -1 times a plus sum. This sign here means sum, addition. Then plus 0 times b. I'm going to put this in brackets so you know it's 0. And then plus the last one, 2 times 0.1. So, and if you calculate this, so this is gone, so we do know that. So, and we do need to calculate a. Negative a, if I move negative a to the other side, it does become positive a. So a is equal to 2 times 0.2 is 2 times 0.1 is 0.2. So, and that would be your value for a. And the next one, part C, it says, use the equation given in part A and your equation from part B. Find the values A and B. So what we have from part A, we have that A plus B is equal to 0.9, and from part B, we have that A is equal to 0.2. Now, those are two equations that we're going to use. If we do substitute the value of A value of A equal to 0.2 into the other equation, which is this one here, so we're going to end up with 0.2 plus B equal to 0.9, and therefore B is equal to 0.7. So now you do have two values, A equals 0.2 and B equals 0.7. If you do want to check if you have correct answers, you do know that sum of all x's is equal to 1. So 0.2 plus 0.7 plus 0.1 and is equal to 1. So that is correct. Now I can see here that my D part of the question, calculate theta of x, it's somewhere down there in the corner. So what I'm going to do, I will calculate this part of the question on the next. Let's find standard deviation of theta of x. So here are the two formulas that we can use. So what I have decided is to use the first one here. But before we start going through replacing the values, I'm just going to show you here, I have copied the table of values from previous page. So probability that x is going to be -1 is equal to a, where a is 0.2. Probability that random variable is going to be equal to 0 is b, and b is 0.7, and the probability is going to be 2 is 0.1. So let's now go back and have a look what I have done here. So equal square root of everything. This sign here, it means sum, addition, sum of all of this, the difference between the random variable and the mean to the power of 2, then times its probability. So the first one, so what I have done, I have used colors, so just so you can see this part here, it's this part. So green one is the green one from the table, red one is the red data from the table. So x, the first one is -1, so -1 take away mean. Mean is 0. If you do remember from a previous page, they said that mean is given and mean was equal to 0. So take away 0 to the power of 2 times 0.2, which is the probability. So then plus, now we're moving to the the next set of data. So x is 0, take away mean, it's 0 to the power of 2, then times the probability that may happen, it's 0.7, so times b, 0.7, and then plus the last bit, to random variable, it's going to be equal to 2, take away 0, which is mean, to the power of 2, and then times the probability, which is 0.1. Now the next part, it would be to calculate this. -1 take away 0 is -1. Any negative number to the power of 2 is going to be positive. 1 times any number is just going to be number itself. So therefore, we have 0.2 plus. The next bit here, 0 take away 0 is going to be 0. It's going to cancel out all of this. So I'm just going to go like this color. Yeah, so it's gone. And then the last bit, 2 take away 0 is 2. To the power of 2 is 4. So if you want, you can just write that 4, 0.1, or you could have, expanded it. So it doesn't make any difference. So altogether, this is going to be equal to 0.6. Again, pay attention to the questions if they're asking decimal places or significant figures or, anything like that. So this one, we do have 3 decimal places. And that would be all for question 1 and 2. And I'll see you in the next video. Thank you for watching. Bye.